Dear viewers, this is VCube here. Today we'll be discussing an important integral which is integral sin x over x dx. Now we all know very well that this particular function has the integral of the function has no elementary antiderivative, meaning its antiderivative cannot be written in the format of late functions. Functions typically includes logarithm, algebra, trigonometry, and then your exponential functions. So we'll have to write this in terms of series expansion. So to do that, we are going to get help from the Maclaurin series. So Maclaurin series states that f of x equals f of at x is equal to 0 times x bar 0 by 0 factorial plus f dash of 0 into x power 1 by 1 factorial plus f double dash of 0 into x power 2 by 2 factorial ellipsis, right? So we are going to first consider the function sin x alone. F of x equals sin x. So its first derivative is going to be cos x. Its second derivative is going to be minus sin x. Its third derivative is going to be minus cos x. And its fourth derivative is going to be sin x again, and its fifth derivative is going to be cos x. Now let me substitute f at x is equal to 0, so it is going to be 0, and f dash of 0 would be equal to 1, and f double dash of 0 would be equal to 0. F at third derivative at x equals 0 would be negative 1, fourth derivative at x equals 0 would be 0, and fifth derivative would be equal to 1. So I can write my sine function to be your f of 0 into x bar 0 by 0 factorial plus f dash at x is equal to 0 into x power 1 by 1 factorial plus 0 into x power 2 by 2 factorial plus minus 1 into x power 3 by 3 factorial plus 0 into x power 4 by 4 factorial plus 1 times x power 4 x power 5 by 5 factorial ellipsis. Simplified, we'll be getting x power 1 by 1 factorial plus of minus x power 3 by 3 factorial plus x power 5 by 5 factorial, so on so forth. So this is your sin x. And now we can write this one as summation. Alright. So you're going to have powers of x. Your powers of x are only odd numbers. So the general representation of odd number is 2n plus 1 or 2n minus 1. I'm going to take 2n plus 1 so that your n runs from 0 till infinity, and your denominator is also taking the same value as the value of the power. So it is going to be 2n plus 1 of its factorial times your negative sign. If you notice down, it is alternating, so it has to be something like minus 1 per n or n plus 1. So we are going to decide whether it's going to be n or n plus 1. So when n equals 0, you're getting your first term which is positive, so it is going to be n, because minus 1 per 0 is positive 1, and we need to have a positive sign for your first term, right? So it is minus 1 per n. If in case if you are having the first term to be negative, you can write it as n plus 1 in this case. So this is your function for sin x. Now we can also write it for sin x upon x, because this is the function that we are asked to integrate. So summation n equals 0 till infinity. So when I divide by x, the power plus 1 simply gets vanished, right? Because when we divide by x, the power goes to the numerator's power and then it subtracts. So you're going to have x to the power of 2n divided by 2n plus 1 factorial times minus 1 per n. And now we are going to integrate, right? Integrate sin x upon x dx. So let me integrate summation n equals 0 to infinity x power 2n divided by 2n plus 1 factorial times minus 1 power n. So whatever is between the integral, only the terms which are having x, containing x, will be integrated. So we are going to remove all the other terms commonly out. So we are going to have summation n equals 0 till infinity minus 1 power n divided by 2n plus 1 factorial out. So integral x power 2n dx. So x power 2n is staying inside. So you are going to have it as summation n equals 0 till infinity minus 1 power n divided by 2n plus 1 factorial. Your x power 2n's integral answer would be x to the power of 2n plus 1 divided by 2n plus 1 plus c. So this is your answer for your integral sin x upon x. So hope you learned something new from this video. Please subscribe us for more such content. Thank you.